So, today I was going to talk about guns and lasers in space, but current events have forced my hand. If you haven't been paying attention to the news, the FAA has been under an immense amount of pressure to revise its decades-old ban on personal electronic devices during takeoff and landing. One Missouri senator wants to go so far as to pass a law overruling FAA regulations. In light of all this commotion, it seems only fair to add a dose of math and science to the whole debate. So let's get down to the main issue at hand. Could a personal electronic device that's not broadcasting in the electromagnetic spectrum really mess with a plane's avionics? Isn't that what airplane mode is for? As usual, the answer is a little more complicated than that. Every electronic device, from a CD player to a laptop, generates a measurable magnetic field. It's an unavoidable consequence of having charged particles moving along wires and circuits. Even the human nervous system has a magnetic signature. If you dissect the microprocessor of a device like a phone, you'll find lots of transistors, tiny electron gates that work together to answer the yes-no binary questions that enable your phone to process more complicated tasks, like high-fidelity physics simulations. There are millions of transistors in any given piece of technology, with electrons zipping through at frequencies ranging from a few hundred megahertz to several gigahertz. Each one is generating its own bubble of EMI, and since a magnetic field can induce current in a wire, it's natural for FAA bureaucrats to worry that your mobile device could disrupt the electronics of a plane. Yet the FAA allows pilots to use iPads in the cockpit, because apparently a handful of tablets next to all the sensitive electronics isn't as big a risk as allowing hundreds of passengers to use mobile devices at the same time. Well, that seems reasonable enough, except it doesn't. Has anyone in Washington ever heard of the inverse square law? The strength of a magnetic field is given by the Biot-Savart law, which looks something like this. For an iPad, let's pretend that all of these variables, evaluated together, equals m. For magic. Then the strength of a magnetic field of an iPad held 10 feet away is equal to m over 10 squared, or 0.01 m. If there were 3 iPads in the cockpit, one for the pilot, co-pilot, plus a spare, held about 3 feet away from the oh-so-important avionics, then the electromagnetic force is 3 times m over 3 squared, or 0.3 repeating m. Let's call this unitless quantification of EMI strength 1s, for Steve Jobs. What would happen if we gave all passengers on a flight iPads? Recently I flew on an Embraer 145, a small regional jet with 18 rows of seats, and for ease of calculation, 3 seats per row. The distance between each seat, or pitch, is about 30 inches, and the first row of seats is roughly 10 feet from the flight deck. Plugging all of this into a fancy number-crunching beast of a program, we have an iPad 10 feet from the cockpit, with each subsequent seat an additional 2.5 feet further away. Since the m can be factored out, we can simply sum up the contribution of each 1 over r squared component and multiply by 3m at the end. It comes out to 0.114 m, or in our units of choice, 0.342 Steves. 54 iPads in the cabin equals 1 iPad in the cockpit. How about for a bigger plane, like a 777? I'll start by simplifying the seating arrangement to 9 passengers per row, with 50 rows. The first row is about 15 feet from the flight deck, since the 777 fits lavatories right behind the cockpit, and there's a little more legroom, so the seat pitch is about 34 inches. The numbers come out to 0.213 m, or 0.637 Steve Jobs. Yep, 450 iPads in the cabin equals 2 iPads in the cockpit. And of course, this is a blatant overestimation of the EMI problem posed by the general public. Kindles and other low-powered tablets have smaller magnetic signatures than the iPad, seating arrangements are actually less dense than I assumed, and of course, not everyone uses a personal electronic device in flight. The FAA does have other reasons for wanting to ban electronics during takeoff and landing though, the fear that your gadgets will become projectiles in severe turbulence. And to that I say, bullshit. There are numerous other objects of potentially perilous proportions that people can keep out during all phases of flight. Some of them are more dangerous than others. Now, I would like to reiterate that the use of wireless transmission features on a mobile device would still be prohibited regardless of the FAA's final decision on overturning the ban. But for the general population, being able to just get by with airplane mode on airplanes instead of completely powering down your devices would be a huge win for common sense. And I wouldn't feel the eyes of judgmental senior citizens burning into my skull anymore while Instagramming Manhattan from 3,000 feet.